Oh, g'day, Mr. Bennett here. Today we're going to be looking at tangents and normals, and exercise 3H really is a bit of revision of the whole chapter. Okay, so all the techniques that you've learnt about how to differentiate terms will be tested again here, but with the application of finding a tangent to a curve or finding a normal to a curve. Alright, so if we just look at some theory, the slope of the tangent is in fact the dy dx or the f dashed, and that is the slope of the tangent. So if we were looking at a curve, alright, so if we're looking at a curve, then what we would say is the blue line here to the black curve is in fact the tangent. So, and then the normal is at right angles to that. Okay, so a normal is always at 90 degrees to the tangent. And so it sort of comes straight out from the actual curve itself. Now over here, if we're looking at this term, okay, the slope of the normal is minus the inverse of the tangent. And I know you learnt this last year, but let's just go through that again. So if we were looking at the concept of what the slope of the tangent might be, let's say you've done your differentiation, you've found the slope, the dyx, to be equal to 1/2, then my slope of my normal is going to be minus 2 over 1, which we would say is equal to minus 2. Right? If my slope of my tangent is 3, well, that technically is equal to 3 over 1, isn't it? So therefore, the slope of my normal will be minus 1 over 3. You just invert it and you basically change the sign. If the slope of my tangent is in fact 2 over 7, then I invert it and that becomes equal to 7 on 2, becomes positive. If I've got a slope of my tangent to be negative 4, then that will become equal to 1 over 4 positive. I think you get the idea hopefully with that. If you do have troubles with that, make sure you talk to me in class about that. So the sort of questions that you're going to get in this first section will be if I get given something like y equals, let's do a quadratic, x squared plus 5x take 7, and we want to find the slope of the tangent at x equals 2. Right? The steps that we've got to go through are pretty basic. So the first thing that we have to do is we have to find the point that it actually goes through. So we have to find, the first step here is step A, is find the point. To find the point that where the tangent occurs, you have to put that into the original equation, because this tells you the y coordinates. So that would be 2 squared plus 5 times by 2 take 7. So that's going to be 4 plus 10 is 14, take 7 is going to give me 7. So the point that we're looking at where the tangent is fact 2, 7. That always will give you information so you can actually find that value. The second step, part B, is to find the slope of the tangent or slope of the normal. Okay, so then to do that we have to do our dy dx. Alright, so we simply do that, and that's going to be 2x plus 5. So when x equals 2, we know the slope of our tangent. No matter what you're doing, you always have to find the slope of the tangent. If you do find the slope of the tangent, then you know the slope of your normal as well, don't you? Okay, so that's going to be 5 plus 4, which is going to be 9. So that's the slope of our tangent. So once you've got that information, then the third step is to put that through to find the equation of the tangent. Okay, so part C is to find the equation of tangent. Now, keeping in mind, to find the equation of any line, you need to know a point, which is 2, 7, and you need to know the slope, which is equal to 9. So it doesn't really matter how you do this, but I generally do it this way. So it's y take 7 over x take 2 is equal to 9, the slope. So then I can rearrange that and say that y take 7 equals 9x take 18, times in the 9 through to both terms. And so therefore, the slope of my equation of my tangent y is equal to 9x. It's going to be plus 7, so that's going to be take 11. So that will be the equation of my tangent to the quadratic at that point. So I think if you keep in mind those steps, this should be pretty straightforward. Alright, so it can be for any function, any polynomial that we actually do this for. Alright, so, but again, the key steps, first step is to find the point that it goes through. The second step, part B, is to find the slope of the tangent. Part C is to find the equation using the information that you got. Alright, so let's just do another quick example for you. Alright, so example number 2, let's say we've got y is equal to, make it a bit harder, x cubed plus 2x squared plus 8. Alright, so therefore, first step obviously is to find the point. Now we're going to do this when x is equal to 1, just because it's easy to do the calculations. Alright, so y is equal to 1 cubed plus 2 times by 1 squared plus 8. So 1 cubed is 1, that's going to be 2, that's 10. So therefore that's going to be equal to 11. So the point that we're looking at is 1, 11. Alright. Step 2 is to find the slope of the tangent. So that's my dy dx. So that's going to be equal to 3x squared plus 4x, and the 8 goes out. So therefore when x is equal to 1, and it's not harder for any other number, but we know the slope of the tangent is going to be equal to 3 times by 1 squared plus 4 times by 1, so that's going to be equal to 7. Okay, so, and then the third step is to find the equation of the tangent. Let's find the equation of the normal in this particular case, so therefore the equation of the normal is going to be equal to minus 1 over 7. So step 3, equation of normal. Alright, so then what we know is we've got a slope of the normal is equal to minus 1 over 7, goes through the point 1, 11. So now it's just a matter of going through and using our formula. So y take 11 over x take 1 is equal to minus 1 over 7, whichever way I cross multiply here. So 7y, it's a bit dodgy. So go 7y take 11 equals negative x plus 11. So I could times that out straight away. So 7y take 77 equals negative x plus 11. So bring that over, that becomes 88. So therefore y is equal to minus x on 7 plus 88 on 7. And that's the equation of my normal going through that. So as I said before, this whole section checks whether you can do your differentiation. So it's a good review of all the exercises in chapter 3 up to now. But it now puts it into context of finding the equations of a tangent, equations of a normal. Alright, so good luck with these, and I'll talk to you about some other examples in 3H in the next video.